All right, let's talk about a term you've probably heard a lot lately, digital twin. But we're going to go way beyond the buzzword today. We're going to explore what makes a digital twin not just a model, but what makes it truly alive. So let's just tackle the biggest question head on. When you hear digital twin, does your mind immediately jump to, a really detailed but ultimately static 3D model? A lot of people think that. But is that really all there is to it? Oh, not even close. A static 3D model? That's just a snapshot in time. A living digital twin, well, that's a whole different beast. It's a dynamic, interactive system that's constantly being fed with real-world data. So think less of a pretty picture and more of a living, breathing, virtual version of the real thing. Okay, so what's the secret sauce? What exactly does it mean for a digital twin to be living? Let's break down that core concept and get right to it. At its core, it's all about being a synchronized virtual representation. The two most important words you see on the screen there are synchronized and interacts. This isn't a one-way mirror. It's a two-way street. Whatever happens out in the physical world gets reflected in the twin, and the insights we get from the twin can actually drive actions back in the real world. And this definition really adds some important layers to that. I mean, check out those key phrases: continuously updated, location-enabled, and the idea that it integrates data, people, models, and operations. See, it's not just something you look at. It's a powerful system that you use to understand what's happening, predict what's going to happen, and make much, much better decisions. And really, this whole idea rests on four key pillars. First, you need a unified spatial context, which basically just means everything is anchored to a single authoritative map. Second, that continuous synchronization we talked about. That's the live data feed. Third, integration is crucial, because it lets totally different teams all work together in the same virtual space. And finally, it's all built for intelligence, turning it from just a visual model into a real decision-making engine. Okay, so we get what it is. It's a cool concept. But why is this tech becoming so critical, like right now? Well, it turns out it's being driven by some massive forces that are literally reshaping our world. It's really a perfect storm of three huge forces. First up is technology. The explosion of IoT sensors and the rise of AI make this kind of real-time analysis actually possible. Then there's sustainability. Things like climate change and our aging infrastructure are demanding smarter ways to manage everything. And third, you've got these big societal shifts, like rapid urbanization, that are forcing us to find more efficient ways to operate. Living digital twins are quickly becoming the foundation for how we're going to meet these challenges. So how does an organization actually go about building one of these? I mean, it's not like you can just flip a switch. It's definitely an evolutionary journey. And this slide shows you that journey. Think of it like leveling up. You start at level 1 with a descriptive twin, basically your foundational 3D models. Then you connect real-time data to make it informative. Level 3 gets really interesting. It becomes predictive, letting you run what-if scenarios. Level 4 is comprehensive, where you can test out entire complex systems. And the ultimate goal, level 5, is an autonomous twin that can actually recommend or even take actions all on its own. And the most practical way to move through those levels is by using this simple 3-phase life cycle. First, you have to scope out the problem you're trying to solve. You have to know your why. Second, you collect all the data you need and build the twin. And finally, you run and operate it to start generating some real value. Now, let's zoom in on that build phase for a second. This is where the magic happens. You're bringing together all these incredibly different types of data. You've got reality capture from things like drones and LiDAR, you've got engineering designs from BIM and CAD, and you've got live operational data from your IoT sensors. But wait, here is the one step you absolutely cannot, under any circumstances, skip: data harmonization. Before you can build anything useful, all that messy, diverse data has to be cleaned up, standardized, and governed, so it's all speaking the same language. Seriously, this foundational work is what makes a truly functional twin even possible. So what kind of system can possibly handle all this complexity? Well, you need a comprehensive platform that can act as the core engine, or really the operating system for the entire digital twin. The right platform gives you all these core functions, everything you see here, all in one connected ecosystem. It goes way beyond just visualization to handle the tough stuff like data management, running real-time analytics and simulations, and integrating systems across an entire organization. And true integration means the platform has to handle it all. It needs to seamlessly bring in that super detailed engineering data from building information models, or BIM.
while at the exact same time it's processing these massive, real-time data streams from potentially thousands of IoT sensors.
And then render these incredibly dense, high-resolution point clouds from LiDAR scans for perfect geometry. And fuse all of that together with realistic 3D mesh data from drones, creating what's essentially a digital skin of the Earth. Now that is what a powerful, integrated platform is all about.
So the technology is obviously impressive, but what does it actually do? Where does the rubber meet the road? Let's look at the real-world impact.
Well, in urban planning, cities are using them to test out zoning changes, simulate how a new development will affect traffic, and even help citizens visualize what future projects will look like. And for utilities, a living twin can model an entire water or electrical grid. This is a game changer for managing outages in real time, but even more importantly, for predicting where equipment might fail before it actually breaks. And of course, in construction, when you integrate your design models with the real-world context of the site, you get much better logistics, you can monitor progress against the plan, and you can spot potential conflicts between systems way earlier. So what are the big things to remember here? First, always focus on the outcome. These are systems designed to solve problems. They're not just pretty models. Second, remember that a living twin is all about that continuous cycle of updates and interaction. Third, follow the process. That clear life cycle of scoping, building, and operating is your roadmap. And finally, the real ultimate value is in the intelligence, using the twin to make smarter, faster, and more confident decisions. And that kind of brings us to one final thought. The world around you, your city, your company, your infrastructure, it already has a digital twin in some shape or form. So the real question is it just a static model collecting digital dust on a server somewhere? Or is it a truly living system, actively helping us all build a smarter, safer, and more resilient future?